Make sure
Yeah,
that.
I'll be watching.
Okay.
Yeah, so you're live, and I
Okay.
can see you looking at the Rust documentation
All right.
and now code. Yeah.
The question is, can you hear yourself?
Oh, let me listen. Yeah, I'm on there.
Okay. Well, then we're doing this.
All right. Have you done any of these data structures in Rust yet?
I have I've done some. I did a linked list. That was kind of the major one that I spent time with because it was fighting with Rust borrow checker. But have you looked at Rust, done any Rust before, Adam?
No. I've
Okay.
done some Reason.
You done some Reason?
I
Okay.
don't know if that's similar.
Um, Not particularly. Rust is still very like C looking. It's got squiggle brackets. It's not ML based like Reason,
Okay.
but it it does have nice type inference though, or at least it does a good amount of it where it can. So let's see if we can do this from scratch. This will be a fun exercise to run through, doing it live. So first thing we want to do is we have this real basic project that is just like one that I cargo initted. You saw that earlier.
Yeah.
And if you want to run test, you run cargo test. You execute that, it will compile it, and it will run all your tests for you. And it says everything's all good because 2 and 2 is equal to 4.
It says running 0 tests.
So there's doc test and test. So it actually runs test inside
Oh,
your
okay.
documentation, but we can actually turn that off. So if you do cargo test and you say dash dash tests, then it won't include the doc test, and then it will just run your test. And you can
Okay.
also hide the compiler output by putting, I think it's dash Q. That'll make it quieter. So if you notice the compiler output is no longer in here.
Yeah.
So that makes it a little bit nicer to read, right? And the other thing we
Yeah.
can do is rather than me having to jump down to this terminal all the time, have you used the enter tool, like this ENTR?
No.
So it is a tool that will go and take some standard input with a whole bunch of file names, and from there it will execute whatever command you give to it afterwards. So in short, if I say find everything in my source folder, it will find all those files in there. Which there's only lib.rs right now. But if I say find source and then I pipe it into this enter, then what it'll say is enter will watch every file that's listed in there, and if it makes a change, it will execute whatever command follows it. So I can say cargo test tests and then make them quiet. If I do that, then it went and ran the test, and then
Okay.
anytime that I make a change here, so if I were to say find my 2 and replace it with 3 or something, I save that, then it will give me back a failure and let me know that 5 is not equal to 4. But
Nice. Yeah, I've never heard of ENTR.
it's kind of nice for a language that doesn't have like a file watcher. Like Cargo's test runner does not have a built-in watch,
Yeah.
and I think that you can get one. I just have not done it because enter does the job for me. I mean, maybe in a more complex case, I might need something else, but if you just need a tool that will work across the board, enter is one worth going for.
Cool. So, what data structure are we going to make?
Let's go ahead and do a linked list. See if I can describe it to you and work through it.
Okay.
So we can see if we can make a new one. So I guess let's go ahead.
So Rust doesn't have anything like a linked list already.
There is a linked list that they have. They actually have a doubly linked list, and we're not going to go to that extent in their docs. They have Rust documentation, or do they have the API in here somewhere? The reference is not a formal spec. Where are their docs at? I don't know. Rust standard library. There we go. And in here they have the Rust documentation is actually pretty solid. At least I've been pretty happy with it. So
Oh,
the
cool.
inside of standard collections, they have a linked list. Generally, you don't want to use it. It says, I mean, even in their docs, they say it's almost always better to use Vec, but they have everything along with examples, and a lot of the examples you can actually hit run and it will go and execute it for you right inside the browser. Like with I don't know, they have like a little REPL or program executor thing in the browser. So it's
That's
kind of,
awesome.
yeah, it's pretty cool that they have that built in just as part of their doc generation. So far, that's been one of my favorite parts of Rust is just having it. So like all the nice tooling that seems to be available, even so early in its lifespan. Like they've got Cargo for package management, which has testing stuff built into it, and so setup is really easy. It's just the rust up command. Once you get rust up and you install that, then you'll have Rust compiler and Cargo, which Cargo will do all your compiling for you, so you don't really need to use rustc. And it also does like doc generation and all that. And you
Cool.
can go and anything you're interested in. So I actually looked at Rust linked list a little bit to see what they were doing under the hood, and you can tap source on any of their stuff, and it will take you right to the line of that thing or of that,
Wow.
and you can go and see the underlying Rust that builds up Rust. And they I've noticed like in some of their uh, common data structures, they actually wind up breaking out into unsafe occasionally because it helps them performance wise. And also, I don't know if there are things that they're running into that they can't normally do. I'm still not way up to speed on using unsafe. I haven't had to use it myself yet.
So parts of Rust are written in Rust, or is that
Yeah.
okay?
So, I mean, I think that it totally is now. I don't know if they achieved that milestone of like everything is written in Rust. Like they built a
How?
compiler that can compile itself.
Oh, right. I think CoffeeScript or something did that.
Yeah, it's the bootstrapping milestone. Like when a language can compile itself, sometimes that can
That's
be
so weird.
the term of then it's legit.
Yeah.
But they do have a linked list in there, so if you want one, you can use that. But and so we can even look at it and maybe model some of the things that it does, at least in terms of interface. So we have our own. But um, yeah, vector is
Yeah. So are we doing this test-driven development style?
um, I mean we can, or at least I would kind of like to do that. I don't think I'll be totally pure on it, but I definitely want to have a level of test suites first. You can hold
Cool.
me to that, Adam. You can say you're
Yeah.
implementing way too much or something.
Yeah. Yeah. Yeah.
Okay. So a I guess the at the core of it, we need to have a struct, and so a struct is it's a structure that holds data inside of Rust. So I mean, you can just say struct and then the name of it. We'll go even with linked list,
Okay.
and why is it mad at me already? Expected one of what? Found linked list.
Oh, you misspelled struct.
Okay, already. That's awesome. I was like, I've written, yeah. Okay,
Yeah.
so I've got myself a struct. Doesn't have a whole lot in it. Actually, in struct or in Rust, this would not have any cost to it because it doesn't really have anything in it. And with a struct, probably the thing that we want to have in our linked list is we want to know like what node is at the head of our thing, right?
Yeah.
So I mean, I guess we can have it like this already. So
So is there a test you can write at this point
I guess
before before
here,
you even write struct linked list?
yeah, I guess I'll go and get rid of even all that garbage. Okay, so yeah, I can say let list is equal to I'll make myself a linked list, and then assert equal list. I don't know what I can really assert on it. But yeah, that's the tough thing. It's like you can't.
Can you
I mean,
assert that it
here,
just exists?
yeah. I mean, I guess just this alone, like given the fact that the test runs, but
Right.
you can see like right now, Rust is trying to be helpful, saying, "Hey, you're asking for a linked list. Do you mean one of these things?" So it's actually going and doing some digging for me,
That's pretty cool.
and I will say, "No, that's not what I'm looking for." And actually, I noticed it's not yelling at me inside of VS Code, and
Yeah.
it should be. So maybe closing and opening it does that. Otherwise, I might actually need to close and reopen VS Code. I've had to do this before where it's required that, so because it should definitely have a red squiggly under it at this point, and it doesn't.
Yeah.
So I will go and cycle that real quick. So open code on this thing, and I have my
There we go.
there's my red. Okay, and now that we have a linked list showing up in here that is nice and underscored red, now we got to implement it. So if I can spell struct right, then we can have ourselves a linked list struct. And now it's still mad at me, and the reason why it's still mad is because I'm not using this outer module. So at this kind of top level that I'm in right now,
Hmm.
I'm in a module. Just being in the file itself means that I'm within a module, and this test happens to be a nested module within it, and it doesn't necessarily get everything from the outer module, or it doesn't get it immediately, if that makes sense.
Okay.
So
Yeah.
linked list is not visible inside of this test module.
Right. Okay.
And so the way that I can do that is by saying use. Like use is how you import another module. So I can say I want to use super, and I'll say use super linked list. And now I have a super linked list.
Okay.
And now this test happens to be passing. Like it's not really asserting anything, but it is at least a test. I can't assert a whole lot else about it right now, at least as far as I know, because I can't test equality on it because it doesn't happen to have equality right now. I mean, I can.
Yeah. So what's the next thing you would add to struct that you could
The next thing
test
that I can
for?
add to struct. So maybe the next thing that I add is maybe I don't know. I could
Are we going to put a method on struct?
maybe I could allow it to have equality. So in order to do that, there is like a derive, and then what is it, equal? If I do that, sorry, I should not be doing that yet. I should be writing a test. So I can go and say I want to assert equal that list is equal to list, because even that, I don't know if I can do that assertion yet. So I'm getting a couple of errors right here where up at the top of this error right here, it's saying that like I'm trying to assert the list is equal to itself, and by default, like a structure you can't check equality on it. Like it's that basic. But if I were to go and say derive and then say partial equals, which I don't know all the in-depth reasons of why they do partial equals, but that is one thing I need. All right. The other thing that it's yelling about is it doesn't implement debug. So debug is a way of just like printing out a structure. I think it is. So if I
So
say
it needs to implement debugged in order to assert equality?
it needs to implement partial equals to equality. Debug, its purpose is like if the assertion failed, then it would need to print it out. So if, for the sake of the test method, or sorry, of the assert equals test function, it needs to have debug so it can print out the error.
Okay.
Does that make sense? Because
Yeah, so if you made a list 2 and assert that list equals list 2, what's going to happen?
right now they're the same because like they byte-wise they are exactly the same because they actually don't hold any bytes right now, so like they are equivalent.
Huh. I would
So
think they're pointing to different structs.
well, it's I guess it's not pointer equality that it's doing, like it's doing like byte-wise equality
Okay.
instead, so like value-based equality rather than reference-based. At least that's what the default of partial equals does. You can go and implement it a different way if you wanted to.
Oh, okay.
But by doing the default, this derive will use the default of partial equals and put it against linked list, which is what we want, I think, for right now. If we need to change it, we can. So let's go and look at the linked list code. And as for its implementation, so stepping back one sec on Rust, so there's not the notion of a method necessarily on a struct in Rust.
Mm.
So a struct is just a holder of data, and
What if that data happens to be a function?
what if that data happens to be a function? So I mean, you can. I guess I don't quite know on how to make a data a function. Like there is the notion of a closure, so or like a structure that is that. But you can go and you have what are called traits. And so a trait is kind of like an interface. If you have you done .NET or Java?
Well, TypeScript has interfaces.
Yeah. Okay,
Yeah.
it would be like that as well, where I mean, I guess an interface would be some contract that this thing can support, right?
Yeah.
And the difference between TypeScript's interfaces and C#'s interfaces and a lot of the other object-oriented ones that you see is oftentimes you have to put those directly on the class. Like you would have to say, this is not actual Rust code, but linked list implements I don't know, like honkable or something, right?
Yeah. Yeah.
And the only person who can decide what interface is implemented by a what interfaces are implemented by a struct would be the creator of it. Like that's how it winds up being in TypeScript and C#, right?
Yeah.
Like,
Yeah.
and what happens with Rust is with the trait, a trait actually can live outside, or an implementation of a trait can live outside of the
Of the struct itself.
yeah. And so like
Okay.
say some existing structure was there, like say I wanted to use one of Rust standard libraries thing, like their built-in linked list, but I happen to have some special trait behavior that I wanted that was, say, like it can reverse itself or something. I can implement that trait for a standard library type struct if I wanted to. So it definitely allows a greater level of openness where classes
Yeah.
enter
Very
seal.
cool.
So you can also do it as well. Like if I don't want to do like a specific version, like if I want to implement it just on itself, because you can also do an impl of linked list unlinked list, which is kind of the way that you do, like gets you method type behavior. you can do that as well, but it also doesn't live on the struct. It's a little bit weird in how they let you do that, but um,
So Rust seems to like very short keywords.
uh, yeah,
Struct impl,
yeah,
impl. Yeah.
yeah. So we have this new. So let's go ahead and we'll keep our test, but we'll write another one of, we'll call it like test new. So instead of doing this, we'll go and change this to a linked list new. And this is a static function. You can tell that because there's 2 colons that are happening there. You see that?
Yes.
Okay. And we can assert that when we new up a list, we can do that. So it's kind of like I mean, I guess this is kind of us making a constructor-like thing, but it's a common paradigm to do. So we want to, or it says new is not associated with linked list, or function, it's not. So we can say impl of linked list, and we can make a function that is called new. And it doesn't take any arguments, and it gives back a self, which happens to be a linked list. You can also put linked list, but self means, like, self with a capital S is in reference to whatever type is getting implemented.
Okay. It's saying it returns that type.
Yep. So it
Okay.
new takes no arguments, and it gives back some instance of self, or so we can say linked list, and we'll get back a new one like that.
Cool.
And I should have red squigglies go away. And now test new works. How about that? And then I can go and refactor my old test real quick to use that instead of the other way of doing it. Save that. They should both continue to work. Yep, so I ran again, which means I can get rid of this. It works. And I guess I will change the name now to test new. So look at that. I have it.
So should our new function take in like an initial value for the first node?
I'm I don't know, I'm in debate on that. Like
Okay, so
like
maybe not.
yeah, that's
So I get would the
because
next one be to
it doesn't look like
add?
theirs brings in one, but
Okay.
they do have appending. They have appending, and do they have like an add or something like that?
Probably before we do append, we should say like what is the value of the current node we're looking at.
The value of the current node we're looking at. Okay.
Yeah.
Yeah, we can.
Which for an empty list would
Yeah.
be nothing.
Right. So yeah, let's actually do this. So that's a good test to write. Thanks, Adam. So I'll say function test, and we'll call it head because that's what it is, right?
Yep.
And we'll say let list. Can I do this? It won't let me do it. It's kind of Vim-like, but I wanted to do line completion, but it wouldn't let me do that.
Oh.
Link list new, and assert equals, and let's see if I can do this. If I say list, what is going on? List dot head, and it should be it'll be an option, and I'll say it's none. I think I can do that.
So what's an option?
So an option is like a maybe, if you've done if you've been used like reason or something like that. So an option.
Yeah, and I've used maybe types in TypeScript as well.
Yeah. So
even though it's not built in.
yeah. So this is it's a pretty common type inside of Rust, and so an option can either be a none or it can be a sum. So if it's none,
Okay.
then it has no value inside of it. Otherwise, it has some value of t. But we have not yet forced ourselves to hold the value type. So right now it's saying method head is not found for this. So it's telling us that it has no head.
Yep.
So we need to do a function to implement that. I'm going to call it head, and it is going to return an option.
And if you just returned something else, it would just fail, saying it doesn't equal what it's supposed to, right?
Oh, yeah. So to see it fail in a, sure, we'll say just 3. And then it's going to be mad at me right here because it says wrong number of type arguments. And we are now getting into, which, because option has to have a type, otherwise it.
Oh, okay. Well,
So,
go ahead and just do none.
well, even without it, it will have to be a none, or like it'll have to specify a type because option is a generic type. So even if I say option none, it's still going to be mad at me that I'm not giving back a type argument. So we'll see if we can make it fail in a different way. So right now we'll say U32, like an unsigned 32, just so we have some type on that thing. By the way, semicolons are important. Like if you have one at the end, it means don't return this thing. Otherwise, it will return the last value.
Oh.
You can use the return
That's kind
keyword.
of weird.
But yeah. So option just. Wait, sorry, not just. Just what is Haskell just? I don't know. Some, not none, or some, not just. Either way.
Okay.
That is, yeah. I think it. Another language.
Now it highlighted some other stuff.
Right. So now it's yelling at me because it's saying this is an associated function, not a method, and so it's telling me that I'm trying to call list.head on an instance.
Right. Yeah.
And so the way that you can do that is you can say that you want to have self, and I'm just going to go and borrow self.
Oh. So would you normally have to use colon instead of dot?
If it's a, I mean, my related mental model is to say that it's colon is like static and dot is instance. That is totally not. I guess that's not entirely true.
You're just trying to translate it over from object-oriented languages.
I mean, that is my closest connection that I have, because I mean really what it means when you use the dot syntax is that it goes and it finds. So when I call list.head, by using dot, it goes to the head function and it calls it, passing it that thing that I dotted against as the first argument.
Oh, cool.
So
yeah, I can see why you would think of it that way.
I mean, if you've written Python, it's in the same sort of way. Where,
so what does the ampersand mean in front of self?
So,
and then I haven't written any Python.
Yeah. So ampersand is a way to say that I'm borrowing this. So it gets into Rust lifetimes. And an ampersand says, I'm going to borrow this value, and when I'm done, you can have it back. So for example, right here where I call list.head, this function is using the value of self. Actually, I mean right now it's not, but we have to have self there in order to to make it happy. So
when it's borrowing it can change that value, and then
so it cannot change it. Like this it's an immutable borrow. So it says I'm going to borrow this thing, but I'm not going to make any changes to it.
We'll
start off without, Willen, and then I can show you what happens. with it.
Okay.
At least as a test of my Rust knowledge so far.
Like,
So
what's the value of borrowing? Like,
so
is it just saying like it's locked up for now, no one else can touch it till I'm done?
so multiple places can actually borrow something, and that's okay. Like if multiple things are borrowing something immutably, that is all right. I mean, if that kind of makes sense. Like, I mean, you can hand out as many immutable copies as you want, right? Like,
Right.
nobody's going to make any changes to it, so nobody's going to interfere with each other. However, you can also say that you want to. Um, there's one option of saying ampersand mute, which says I'm mutably borrowing that thing, and that'll
Hmm.
say nobody else can borrow this thing. Like when you're doing that, it's kind of like a now I'm like this thing is using it, and
And
until
then when
I'm
you give
done.
it back, it gives back the changed version.
Yeah, at least assumed to be changed. I mean, it doesn't actually have to be changed, but
Possibly
it,
changed.
yeah, it goes under the assumption that it will be changed. And then if you don't put any ampersand in it at all, then you're claiming that you're taking ownership over it, which means I'm taking this and you can't have it back.
Oh,
So, um, like, I can show you what happens because it gets handled at compiler level. We'll make this pass first, and then we'll go and step through that just real quick. But
okay.
so our test is failing in a good way now, like it's an assertion failure rather than a compiler failure, and it's because we are trying to match list.head, which is giving back a sum of 3, and really what we're looking for is an option none, which is probably what we
I
want
love
right
how it says left and right.
now. Oh yeah, instead of expected and received, or
Yeah, because I think expected and actual gets confusing sometimes.
yes,
Like which side is expected on? Like,
yeah, somebody who's written too many assertion libraries has thought about it. And okay, so now we're green. So let's talk a little bit about it. So I've got this list.head right here, right? And I want to assert that
mhm.
option is none. So right now my function number 9 is taking ownership. So it's saying I now own the list. Like
Mhm.
even though it's being called on list, you have to remember that like this function is not actually part of list. It is like it is a function, like it's an implementation of the linked list trait by linked list.
Right.
And
Yeah.
so you just think of it more like a floating in space function. So this is where it kind of takes the departure from object oriented, where like if you call some method on an object instance, it's it's not going to like take ownership of it because you assume that it is part of the object, right?
Right.
But um, the difference is this just gives us the nice dot syntax. We could also put these things not inside of the linked list impl, and then we could use them like a normal function as well. Like this is legitimate syntax other than the self thing as well.
Okay.
Um, all right, so are we still passing? Okay, so now because this list.head function takes ownership of it,
Yeah.
I can no longer use like in terms of like
You can
within
no
this.
longer. So if you duplicated line 28,
Yeah.
that won't work.
So now, yeah, you watch it, and the compiler starts blowing up and yelling at me again. And the reason is that it says value used here after move. So it's saying head was given or list was given away to the head function. Like ownership was given to that head function, and it was never given back. Like it asked
That
for.
that's a bit confusing, right? Like if you don't know the implementation details of head, you can't just look at line 28 and 29 and see any problem.
Yeah, you can't, but I mean that is why the compiler will yell at you about it. And I guess looking at the implementation of head, if of course now I hover over it and it's not showing it, maybe because the compiler's failing. But either way, yeah, like it's part of the type signature and saying like how it's going to treat that thing that you're interacting with.
Okay.
And the reason for it is that Rust is I guess it's not a garbage collected language, and instead it tracks the lifetime of objects during compilation. So, have you written any C or C code?
Yeah, in college.
And you had to do like lots of mallocs and frees, right?
Yes.
So, if you kind of think about what the compiler does here, like you notice there are no mallocs and frees going on, but
Right.
somewhere along the line that's happening, right?
Mm-hmm.
And in the way that it works in a garbage collected language is you new up that thing, and your language will go and it will create a reference to that thing. It'll allocate memory if it needs to in its own maybe virtual machine or something, and then it can do like mark and sweep or reference counting to see like is this thing still in use. And periodically the garbage collector will say, all right, our application's using a lot of memory, I need to go and get rid of stuff, and then it'll free that memory up, right?
Mm-hmm. Yeah.
And in Rust it doesn't work quite like that, and instead um, it it actually goes and builds in those things just through how your type system declares how you're going to use it. And so you can kind of think of this right here as a like malloc, and I really hope nobody's watching this Twitch because I'm probably horribly wrong here, but like
Yeah.
and
No,
just,
you're good. You're good. Just me.
all right, sweet. um, so you can kind of think of like this right here, it's doing a malloc because ultimately we're saying like we want an instance of this struct on line 6, right?
Yes.
So
That's how you learn, right? You be wrong on the internet, and then someone tells you you're wrong, and
yeah,
then you win.
so that's what I can hope for. I've made mistakes like it before, and it feels right. At least I've convinced myself that I'm on the right track here. So um, what happens is when I call this list.head right here, I take ownership of it, right?
Yeah.
And then it goes and it runs this head function, which has a reference to self, right? And then what can happen is now I'm at the end of this function, right? And like there's nothing left to do, and self is no longer used. I haven't handed it off to anybody else. Like I haven't borrowed it to anybody. I haven't given ownership to anybody else. And so the compiler can say free,
Free.
like free whatever self is, like the self in the size that it is.
Yeah.
And so that's kind of what it does. I'm sure it does it at a far more optimized way, or at least I would assume. But either way, it knows that because of how I'm talking about it. So at this point, um, list like list is free. Like
Yeah. So it doesn't
so
exist.
right, and so that's why I'm getting yelled at here. At least it goes under the assumption that list is freed right there. Like
Yeah, it may still be hanging around. The garbage collector may have not actually gotten rid of it yet, but you don't have it.
well, I mean there is no garbage collector though.
Oh, okay.
So
Well,
Rust doesn't have a garbage collector,
hmm.
and yet you don't have to write malloc and free all over the place because of how you declare your types, like and how you're using something. So right here we can see once again, like we did the malloc here, we handed ownership over to this list.head, and then inside of the head, like it used self or didn't use self. I mean, it's at its discretion to do what it wants because this is the owner of it right now. And
I do what I want.
yeah,
It's a honey badger.
and then afterwards, like the compiler knows that self is no longer in use. Like it ownership is there, but now this function is like the stack of this function is gonna go away, like the stack frame's cleaning itself up, and it can go and free self. Like for sure, it can do that.
Cool.
And
So looks like someone may be watching now, and
awesome.
what we're doing is trying to implement a linked list using Rust. And I don't know Rust, so I'm also learning it.
And I only know a little bit more, so this is kind of like, I mean, the noob leading the noob, and so I could be horribly wrong here, but from at least what I gather is that after this invocation, you can assume that the list is freed, or the compiler goes under that assumption. And so trying to call list.head again right here after this head right here took ownership of it and freed it afterwards, I'm not
Yeah.
able to go and interact with it here. Now,
So if you just change head to merely borrow self, it should work.
yeah, then if I tell it to borrow, then it will pass. And the
Is that
reason
an actual Rust term, or is that your word for
to
it?
borrow, that's a
Yeah.
Rust term.
Okay.
So now what is happening is I have this malloc, and the borrow says like you can use this thing with inside a head, but at line 20, like after line 28's done, like we still have ownership overhead. Like ownership starts when we create it on line 27 right here,
Yeah.
and we continue to own that thing even after line 28 is called and line 29 is called. And now after this function's done, it can do a free of list, whatever its
Gotcha.
pointer, like actual pointer is, and so forth. But um, that's kind of the difference. Does that make sense?
Yeah.
Okay. So I'm glad for the feedback on it, and it's a different mental model, and so you wind up baking a lot of how you're going to be using something into the type system, and that allows it to operate without having a garbage collector that stops the world.
Interesting.
Yeah. Okay.
All right. So
All right. So now,
should be returning a none.
yep.
Yeah.
So
I guess that's all we really need to test there until we actually add something to the list.
mm-hmm. So yeah, let's go ahead and add something in, right?
Yeah.
And then we have our head function that can assert behavior for us. So we'll say we got a list, and do they have a term in there, linked list, just so I can kind of mimic this thing? Hey, it shows like a little number 2 on the top corner of my Twitch, so maybe that does actually mean somebody else is watching.
Huh.
All right, so they have append, but I don't really want to append another linked list right now. That's asking more than I want. Push, yeah, push front, push back. Let's just do a push.
Yeah.
We're not gonna do, because push front and push back would require doubly linked, and we're not doing doubly linked.
No, we're not.
We don't. I don't have time for that.
Well, I think push back does that mean you can add to both sides of the list?
Yeah, because this is a doubly linked list, it actually holds a reference to both ends of it. It's
Interesting. Even with the W list, I didn't realize you had the two spots at once, or you could add to both ends at once. I mean, not at once, but like either end.
mm-hmm.
Cool.
So we'll go ahead and we'll do that by
Or we could be weird and call it unshift.
unshift. Yeah. Unless that was already used by a library that existed 15
I
years
can
ago.
never remember what unshift does in JavaScript.
Yeah. It's kind of weird. But all right, so let's do our list dot push. All right, and we're gonna go and push something onto it. Let's push on 42 because that's what people do, right?
Totally.
And after we do that, we want the head of our list to be and option sum 42.
42.
And now we're getting method push not found for this linked list. It says, I don't know what you're talking about.
Nope.
Hey, look at that. They actually do call it a method. So maybe,
Interesting.
yeah. I mean,
So you were wrong.
yeah. I mean, but at the same time, when it's implementing something else, is it a method just because of the invocation style of it? Maybe that's why they refer to it as a method.
I don't know. I'm not the Rust expert.
Yeah, I'm not much of a pro either, but let's do this. So let's do an append. I keep saying append, but it's push. And we're gonna push, and let's go ahead and push onto self. And we're not gonna return anything from this because it's just gonna go and
Oh, so if you're not returning, you don't even need the little dash greater than
because
arrow thingy.
yeah, because the arrow is saying like I'm returning it.
Oh,
Doesn't this look like
that's just.
reason
It
syntax?
looks like an arrow. I don't remember reason. It looks like an arrow function,
Because
but I guess it's more like your signature.
yeah, I mean I mean it's definitely like the Haskell syntax, where you have a like function that takes a function, at least their type signature function.
Yeah, it looks like that.
So, um, yeah, so that's kind of what it seems to be mimicking. So if I have this function push, and push something onto it right now, um, it says expected 0 parameters. So I also need to take something into it, and
Okay.
yeah, say like I don't know, item, sure. It's gonna be this U32, and then I should. Oh, I'm getting one other error that says. So I have a second argument that I'm taking in for it, but it's saying the name test head is defined multiple times because I did not rename it. So if I find head and replace it with push, and test push on that thing, now it's telling me that I'm giving it back none. So I push method works, but now
Cool.
both my head and push are a little
It
bit
totally works.
yeah. Well, I mean it not totally
It exists.
Yeah.
It
Yeah.
exists and it takes in the right parameters.
Right.
All right.
So
How's it gonna save this? That's what I don't know.
how's it going to save this? Like let's get onto that. So right now our struct doesn't have much data inside of it.
No data.
No, there's nothing inside of it. So we're not doing so.
You could just make head randomly return 42 or none, and then test will pass sometimes.
Yes, that's what we want is non-deterministic tests. That's everybody's nightmare of continuous integration.
Oh yeah, so are we gonna actually put something in the struct? The
Yeah.
struct part of the struct? Yeah.
Mm-hmm. Yeah. So
Because right now I have no idea what a struct is, except it apparently holds stuff.
yeah, a struct can hold other values. So let's go ahead and we need to have a actually even yeah we'll make something that we want to put in it first. So let's create the notion of a node in our linked list.
Yeah, totally.
And a node happens to be a
Like a value and a pointer.
and so yeah it'll be like a value, and that will be some type. We're gonna change these U32 out real quick because I don't want it to just be stuck to unsigned 32, but we'll make the thing compile first, and then because that's our an additional step to our TDD is making sure that the compiler compiles. So we got value of 32, and then we can say like next or something. And every node should maybe have another node following it, right?
Yeah, and if there's nothing, it's I guess
Right. And if
a
it's
null or a none.
right, and so if it's a maybe, then we'll say then option it's got another node. So we save that, and right now we're getting this awesome error that says recursive type node has infinite size. And I've run into this before, so this is not that scary, but infinite size does not sound good given our laptops have finite amounts of memory in them, or our computers have finite amounts of memory. And
No, it's just it's the Turing
yeah,
machine with infinite tape.
yeah, if we had that, then like this would be no problem. Rust would work perfectly on it.
Yeah.
But so maybe someday when we manage to come up with that.
All you have to do is when you run out of memory, add another hard drive.
There we go. But yeah, but who knows how many hard drives we need to have to even start this thing up or to initialize that. And that's the compiler's problem here as well, is when it goes and right here when we do this alloc, right, or this malloc, or our pretend malloc, whatever it actually does under the hood,
What is malloc
memory
stand for? Alloc
allocation.
means allocate, right?
Yeah, so like memory allocation or
Right.
something.
Yeah, yeah.
And all right, so anyways, when it asks for that, it needs to ask for a certain amount of memory so it can fit that thing in it, right? And right
Hmm.
now, it's saying a node it holds a value and happens to hold some other, potentially another value, which is a node that holds a value. And so that's why it's
Just
mad,
nodes all the way.
right? And so our compiler is actually really helpful to us. And it says insert an indirection, example, a box or an RC or an ampersand if you want to just have a borrowed form of something.
Hmm.
And in our case, like a box is a way to say, I want you to go and put some memory onto the heap. So everything right now that we've created is stack allocated.
Hmm.
You've heard stack and heap, right? A little bit.
Yeah, I'm not super familiar with the heap
Yeah,
because stack. Yeah, I know about stack.
yeah. So the stack is like the kind of lexical scope that you're working within. So like when I create list here, like list is onto the stack,
Hmm.
and then when I go off of here, it removes that from the stack. Like that's how it knows to clear everything out.
Yeah.
And the heap, I guess I think of it more like it's like I don't know, a pool, like where there's lots of memory that's available, that stuff can be floating all over. And when you want to access something from the heap, you have to have a pointer or reference to it. And so what a box will let you do is say, I want to have this thing, but I want to have it on the like I want to have a pointer that exists on the stack. And
Gotcha.
somebody is probably like using the term pointer is probably a terrible misuse of it. But hey, look at that!
It
It's a
says a
pointer type
pointer type.
for heap
You're
allocation.
right.
Whew. Thank you, and little helper box. Yeah, it just proved me right. So
Thanks, thought bubble.
yeah, so now we have this thing that says, all right, a node holds a value that can potentially hold a pointer to another node, and so a pointer is a
So it
fixed
knows
size.
how much room. Yeah, it's
Like
fixed size. So it knows how much room
yeah,
to
a pointer
allocate.
will be like 64 bits or something, and because it's a memory address, that's all it is just um, something
Yeah.
that, and then using that memory address, it knows how to go and extract that so it can like get the actual underlying node. But,
Sweet.
so now we have our recursive structure with the box's indirection, and the compiler I think is happy now, right? Let me save it first. See if it. All right, sweet. So now we don't have compiler failure, we have test failure, which is better.
Yeah.
But we're also not using our node yet. So let's go ahead and on our linked list, let's go and add I don't know what to call it.
Like a head.
Yeah, I mean, we have a method head, and technically you can do it where, let's name that, I'll call it first, or node, I don't know.
Yeah.
Would
First.
first or node make more sense to you? Because it doesn't matter too much.
First makes more sense to me.
Okay, So we'll say first, and first happens to be a node.
And
Well, it
actually, I think head would make the most sense to me. And then the head function, I think the head function is kind of like peak. Like, what's the value? I think head should return the value of the current node you're looking at rather than the head.
oh, head should return, so it should be peak.
Yeah, maybe. I mean,
Yeah,
that's is that kind of what we're thinking of? Like,
yeah.
you're using a linked list and you're currently
So
looking at
oh,
some
so we'd
node.
want like a pop to actually go and take the head of it off or something, like
Yeah,
push and pop, and then head would be peak. Yeah. Okay.
yeah.
I'm I'm good with that. We'll refactor in a little bit, but for now we can actually call this head and it's acceptable. Like it knows the difference between a method call and accessing some uh, property off of the structure.
Okay.
Okay, so first our head, we're not always going to have a head because like right here, like because every node has to have a value, right?
Mm-hmm.
And right here, when we new up this linked list, like we're not going to have, like if we created a default node in it or a initial node in it, like we wouldn't have
Right.
some value to assign to it. And
So is it an option node?
yeah, so now it will be an option of node, yeah. Okay, we save that. And it says binary operation double equals cannot be applied to option node. And so what it's saying is that this node does not also implement partial equals.
Oh,
And so like partial equals requires, like the default implementation requires that all other children of this thing also know how to do it, if that makes sense. So like
yeah, yeah,
it can't check equality if it's nested things underneath it can't. So if we say that,
yeah. Does node have to have debug as well?
does node have to have debug? I guess it doesn't. At least I don't think so. Yeah. Nope. It seems okay. So let's see. Does not implement format debug. Oh, apparently it does. Maybe debug
Ah,
requires all child members to implement that too,
yeah, okay.
but that's okay. It's really easy to implement debug. And and thank you for questioning it because now
We
I
just
know.
did it.
Yeah.
Okay.
So we are now, when we're newing up this linked list right here, it says we're missing head. And this is where we benefit from having the new, is rather than forcing everybody who consumes this thing to have to put a head on it that is an option of none, we can instead um, have just our new function take care of creating an option dot empty, or sorry, an option none. Okay. Now how are we failing? So are we failing in the same way we did before?
Hmm. Yeah.
Okay. So with our head, that lets us go and peek at the current value, which is fine. Okay, let's go and first, I guess we'll make the test pass. I want to get rid of the U32s, but we'll do it after we make it pass. I want to do it with a generic instead, but
Okay.
we won't dive into too much at once.
Yeah.
So if I go and now on this push, I actually want to say I'm going to change up this dot head. There's self dot head. Yeah. And I want the, it's right here. And I'm going to say self dot head happens to be a node, because we're going to put a node on this thing. And we're going to say value happens to be item, because we're getting an
Mm-hmm.
item passed in. And then the other thing that we need is to have the next of that thing. I want it to be the current head, right? I mean, I guess we're not really asserting too much on that,
No, next will be a none,
right? Yeah,
but the previous
yeah. For right now, you're right. Like,
the current location needs to point to the new one you're adding.
so the oh the current location. Yeah. So self.head.
Oh, okay.
So now we're saying
Self.head self.head
is he?
happens to be the current location because we right
Yeah,
now we're
yeah.
only
Because
adding
every
one
time we
value.
add, it's going to be on the head of the list.
Oh, right. The head is actually moving to the end of the list every time.
Yep.
Okay.
Yeah. So um, and then every
It's
new
a good thing we
item.
didn't name it first.
Yeah. Well, I mean, it kind. Yeah. I guess that's why head is. You're right. Is a better term. So yeah, if we set self.head equal to a new node that has our new value on it, and then what we eventually I think want to do is get to the point where we say next is self.head, so we can get the previous one, right?
Yeah.
So that way, like that's what's building our chain is each node knows about the previous node that was in head, and it's okay because it's an option, but we're not testing any of that right now. So
Right.
because we're
Right.
not testing it, we shouldn't need to do that. So let's go ahead and look at our type
It's
errors.
kind of cool how it points to the code that way.
Yeah, how it wraps
Wait,
around.
it's pointing to two different parts though, right? So it's pointing to
Mhm.
node and it's pointing to the end bracket.
Yeah, man, that is impressive
They're
that they, yeah, that they
like
do.
drawing you little pictures.
Hmm. So, yeah, their compiler messages have improved a lot since I tried once before. So, what it's mad about right here is it's finding option, or it's expecting option, but it found struct node.
Right.
So, instead, we can, or because it wants that, we can say option um, sum because we have something
Hmm.
given it, and then we give it that. Yeah, I guess we don't have to return anything. It's going to do the way. Okay. Now we're getting a different error. I mean, I guess I could have hovered over it and it would tell me the same thing. So it says cannot assign to field self head of immutable binding. So you have a
That's
guess at
slightly
what the problem.
different wording. Down below it says cannot mutably borrow field of immutable binding.
It says that too. It
Oh, okay.
yeah, it's just slightly different formatted. But yeah, any guesses on what to do?
Okay, so you can see all of the code.
Yes.
Um, Interesting. No, I don't.
All right. So the key thing here is that it's saying
Oh,
that.
wait, hang on.
Okay.
Okay. So you're borrowing self,
Mm-hmm.
but then you're trying to assign to head.
Right.
So yeah, I'm not sure how you fix it.
Yeah. So way to fix it is this nice blue text right here, being helpful.
Hmm.
So use mutable self. And so instead of just taking in self, we're saying I'm going to borrow self, but I'm actually going to make changes to it. So this is where I say mutable self. And then I do that. And
Okay.
now we,
Cannot borrow mutably.
yes. So um, that is another thing that it's pointing us at. So where is that at? Is it? It's kind of weird that it's not lighting up inside my
49.
test. Maybe,
Yeah.
but it only seems like the test are the place that it doesn't do it. Maybe because this isn't compiling tests in VS Code, but it is here because I'm running tests. Because I know tests don't always run otherwise.
Uh,
Let me test something. Right. So if I do that, does that give it to me? It doesn't. I don't know. But it's not giving me errors inside my test, but it is here. So I can read the output here, and it says that I should consider changing this to a mutable list. And so another thing that you can do is when you allocate something, you also, like when you store it or take ownership of it even, like you need to
Hmm.
say that I'm going to actually be making changes to this thing
Okay.
because it's immutable by
So
default.
let is immutable.
So let is not mutable. So everything is let. So don't let the JavaScript let fool you.
Ha
Um,
ha ha. Yeah.
yeah, and instead, just know that this is a variable binding. You can almost think of this like const, and to say that it is changeable, but it's even const the whole way
It's
in.
stricter than constant
Yeah, like
JavaScript.
you can't change the underlying bytes. It says no.
Yeah.
Like Rust is watching, like the compiler is watching, and it will slap you if you try and change it. So it's not like JavaScript where you can just dot in and like not have those guarantees.
JavaScript looks the other way.
Right. So if we say let mutable to say this list is something that's going to change, now we're back to a failing test again, but we're pushing on. So we're getting so much closer, aren't we? I mean,
Yeah, I
I
guess.
like I guess closer in that the compiler is passing even after we did this thing, and it's
Yeah.
calling this function, and it's not blowing up in the process.
Yeah.
So
That's good.
that I will call that progress right there. So
All right,
now,
let's call it a day.
yeah, red, green, red, don't come back to yeah. I mean, I guess there's the whole like leave the context with a failing test. I don't know who said that, but that is a thing
Right,
I've heard.
yeah. Because if you leave when you're stuck in the middle of a problem, your brain will keep working while you're gone, try to figure it out.
Yeah, and then
But
when you
if everything's good, you don't need to think about it when you're gone.
return, you'll have the context brought back to you. So even if your brain does like go to other things and you read Twitter or something, um, when you return, you get all of that. Like, oh yeah, I was working on this thing, versus like if it's in
Yeah.
a perfectly working state
It's
and
like,
you're only
what
half
was I
implemented.
yeah, what was I doing? What do I need to do now?
Yeah. So
Yeah.
here, our problem actually falls to being head, and um, we can go ahead and we actually want to read values off of it now, right?
Yeah.
Okay.
Yeah.
So the way that we can do that is if we say self and we get that head property off of it,
Hmm.
and I don't know if property is the right word. Maybe it's member. I don't know. I have to figure out my terminology so I'm not screwing up everybody's googling or
Right.
even my own googling. So we can go and one way we can do that because this head is actually at peak. Like we did talk about that, didn't we?
Peak?
Yeah. So
Oh, right.
yeah,
We talked about renaming the
yeah. We'll
function
we'll
to peak.
refactor after we get the test passing though. But
Yeah.
that is the behavior we're taking. So we're gonna look at it, and if there's something there, then we will read the value out. Otherwise, we'll give back option none, and that should make both of our tests pass.
Yeah.
So if we match on self head, then we can say option of sum, and then say some value. I guess it'll be a node, right? Then in that case,
Yeah.
we want to say
Node
node
dot
dot
value.
value. Yeah, and option none. I mean, I guess with none. Otherwise, I just regardless of the case. Underscore just means unused variable,
Okay.
and which matches everything. Have you done pattern matching?
I've seen a little bit of pattern matching in Elixir. I think is Elixir. Crystal. It was Crystal.
Ah, yeah. So pattern matching is I don't know. You can kind of like you can think of it like a more advanced switch statement if that helps your mind wrap around it, where you can say, all right, I'm matching against this thing. If it matches this like the left side of the arrow, then you can go and you can do destructuring. So if it matches in option sum, then I want to bind a variable named node and then make it available on the right side of that. Or
Okay. And it probably needs to be an option.
Yep, that's what it's yelling about.
Nice.
So it's telling me I found an option. It expected an option, but it found a U32. So I can say option of sum and do that.
It's just some node value.
Right. So self.head.
It's like it's so dismissive. Like, it's just some node value.
Right. So here is a little bit tricky of one. So let's see if I can figure this one out, because it's one that I ran into before. But what is happening is that we're moving out of borrow content, and the way that we are doing that is we are taking node. I guess we're taking node off of the head. Or sorry, we're taking node off of self because it happens to be head right here.
Yeah.
So right here we are making it available right here, so that that's taking ownership right there.
Mm-hmm.
And there is a way that we can deal with that. All right, let's try and go ahead and we can do this. We just say we want a reference to it. Does that work? That works. Okay.
Wow. Nice.
So we're saying like right here when we're binding node, it's, see how it says ampersand node?
Yeah.
So that's saying that it's taking a reference on it. Because you can't.
So why do you say ref there instead of ampersand?
I don't know if it's because it's not legal syntax there. But that
I like
is,
to think of it as a referee.
Yeah.
Yeah.
That's
So, yeah, it's just making everybody happy. It's
yeah, it's making sure everybody plays by the rules.
Yeah.
Okay, so let's first do this. We'll find all of our head cases, and I guess not that one or that one, but this one, and call it peak.
Yeah.
Test peak. Test peak.
Because I know peak is a common function in stacks and queues, or one
Yeah.
of those.
Yeah, I was actually looking up stuff about that for the Book Bites podcast about like using a linked list for a stack. And
Oh yeah,
because you really can, and
totally.
there are two types of stacks. They are, I guess, linear stacks and dynamic stacks. And a linear stack is often allocated by a vector of some sort. So a vector or an array, I guess, would be the underlying thing, where it is some, I guess, continuous range of memory. Like when you allocate an array in like C or C++, like it's a bunch of bytes that are all together, right? And that's what gets used by a stack implementation, is you're just putting stuff onto that range and you're removing stuff off. And a linked list, like you can use a linked list like a stack as well, just keeping like a reference to the top thing, kind of like we're doing here. And a pop is just moving off of that. But these bits of memory is like every time we go and allocate a node, it's not necessarily in line in memory, if that makes sense.
Yeah.
So
yeah, totally.
There are actually, I mean, yeah, there are a bunch of places on the heap that may not be touching each other, and so you can lose performance because of that, because CPUs and memory, like it reads really fast to read all together, but reading from random parts of memory is slower. So, yeah, there's perf trade-offs for it, but you can
Hey,
dynamically size. Yeah,
so on your live show, but the screen is black.
the screen is black. Oh no,
Yeah.
that is not good.
What is OBS doing?
What is OBS doing? Oh no, why is it black? Let's take a look at you, OBS.
Why is it black?
Um, I don't know. Can you see it on your screen share?
Yeah, I can see it in Discord, but not in Twitch.
All right. Let's see then. If I hide that and show that.
Is it on the screen anywhere? Can you move it around in that little area? Well, inside of OBS, where it's showing the black rectangle, yeah, there's something you can move around, but it's
Right.
not working.
Oh, that is not good.
Maybe try turning off the streaming and recording and seeing if that does anything.
Let's see. If I hang on, if I do this real quick, and then
Oh, okay.
say that once again. Is it because I had to start or like restart it? Didn't I like?
Oh, maybe because you restarted code.
Yeah, maybe it's been
Wait.
busted since then.
I don't remember. I was thinking it was on Twitch, but I was not looking. I may not have noticed that it was not showing.
All right. Well, that's great. I guess I'll stop and start it over, and we'll have to check it out in a bit.
Yeah.
Yeah. Let's see.
It just